Welcome to Maths and Science by IITian channel. In this lecture, I will be talking about diagonalization of a matrix. What is diagonalization? How it is to be done? And what are the benefits of it? Diagonalization of a matrix is a very important aspect in matrices and also in linear algebra, especially when a matrix is given, how to represent in the diagonal form and what are the steps to find out to represent it in the diagonal form and what are the uses for it. If in the diagonal form, if this is the matrix A and if it can be represented, a diagonal form of A is D, diagonal form. Then D is equal to P inverse A into P. From this what we get is that if I want to find out A to the power of n of any matrix, then P into D to the power of n into P inverse. From this, we can find out the value of A to the power of n. It involves finding eigenvalues, eigenvectors, and inverse of a matrix. That means it is going to clear your concepts on how to find out the eigenvalues, eigenvectors and inverse of a matrix. Along with this, with this lecture, you will be understanding the diagonalization of a matrix, and if a matrix A to the power of n to be found out, like A to the power of 100, then how it is to be done. Let us dwell into the problem. Question is, diagonalize a matrix. What is the matrix given? 2, 3, 6, 7. I have taken a 2 by 2 matrix. For simplicity, you can take 3 by 3 matrix also. Now, what are the steps involved? First step, to find eigenvalues. We have to find the eigenvalues for diagonalization. How eigenvalues can be found out? A minus I lambda determinant is equal to 0. This is the characteristic equation. Characteristic equation. From this, we will get 2, 3, 6, 7 minus lambda into 1, 0, 0, 1. That is going to be matrix 2 minus lambda, 3, 6, 7 minus lambda. That implies determinant of 2 minus lambda, 3, 6, 7 minus lambda is equal to 0. That's what is the characteristic equation. Now we will find the characteristic equation, and from that we will find out the values of eigenvalues. What is it means? Cross multiplication, as I told you in many of my previous lectures. This gives the value 2 minus lambda into 7 minus lambda minus 6 into 3 is equal to 0. That implies 14 minus 2 lambda minus 9 lambda plus lambda square minus 18 is equal to 0. That implies lambda square minus 9 lambda minus 4 is equal to 0. That is in the form ax square plus bx plus c is equal to 0. Here what is the value of A? A is equal to 1. What is the value of B? Minus 9. What is the value of C? Minus 4. That implies lambda 1 and lambda 2 are given by minus B, that is 9 plus or minus square root of B square, that is 81 minus 4 AC, minus 4 into 1, that is 16 whole divided by 2A, 2 into 1, that is equal to 9 plus or minus square root of 97 by 2, lambda 1 and lambda 2. These are the values of lambda 1. Lambda 1 let us say with positive value 9 plus square root of 97 by 2 and lambda 2 is equal to 9 minus square root of 97 by 2. Now, lambda 1 and lambda 2 are come. Next step, second step, to find eigenvectors. Eigenvalues we have got. We have to find the eigenvectors. To find the eigenvectors, for what is the value first lambda is? Lambda 1 is equal to 9 plus square root of 97 by 2. For this particular value, how eigenvectors are to be found out? You put these lambda values in A minus lambda, this lambda value in A minus lambda matrix. A minus I lambda matrix will be, because we know the lambda value now, A minus I lambda, what is the 2 minus lambda? 2 minus lambda means 2 minus lambda 1 is 9 plus 97 square root of by 2. This is one value. 2 minus lambda 3. This 3 will be remain same. This 6. Next 7 minus lambda. 7 minus 9 plus square root of 97 by 2. This is another. Next, if lambda 2 is taken as 9 minus square root of 97 by 2, then how to write A minus I lambda in the similar way? 2 minus 9 minus square root of 97 by 2, this is one value, and 3, this is 6, then 7 minus 9 minus square root of 97 by 2, this is another. That means this is for lambda 2 and this is for lambda 1. We got two matrices. Now, you try to understand the procedure. It can be applied for any matrix to find out the eigenvectors. Eigenvalues, we have done the sufficient examples. Now, in this eigenvectors, try to be very systematic in finding the eigenvectors. When lambda 1 is equal to, when lambda 1 is considered, the matrix is given as 2 minus, let this be multiplied by x. This vertical column, let it be multiplied by x and let it be multiplied by y. Now, 2 minus 9 plus square root of 97 by 2. This is the procedure for finding the eigenvalues, eigenvectors. Plus 3y is equal to 0. This is one equation we have got from the above matrix. Then you make this x and y, multiply with x and y and make it to 0. 6x plus 7 minus 9 plus square root of 97 divided by 2 whole into y is equal to 0. This is the second equation. First equation and second equation we have got. For the eigenvalue lambda 1. Now, how to solve this equation? Let us simplify both of them first. 2 into 2 is 4. 4 minus 9 minus square root of 97 by 2, this whole into x, plus 3y is equal to 0, and 6x plus 14 minus 9 minus square root of 97 whole divided by 2 into y is equal to 0. Then these imply minus 5 minus square root of 97 whole divided by 2 into x plus 3y is equal to 0. That implies x is equal to 6y. When you take x on the other side, it becomes positive 6y by 5 plus square root of 97. These things, this is a little arithmetic algebra equations, you have to solve them. Now, put y is equal to 1. Follow the procedure. That implies x is equal to 6 into 1 by 5 plus square root of 97. For the first row only, this is equation 1. For the equation 1 only I am solving. That shows 6 by 5 plus square root of 97. When y is equal to 1. Then, in the second equation, 6x plus 5 minus square root of 97 divided by 2 into y is equal to 0. That implies this is from the second equation. Put y is equal to 1. This is 14 minus 9 minus square root of 97, 5 minus square root of 97. 7 minus 14 minus 9. Sorry, this becomes 14 minus 9. Minus into minus is, here it is 7 minus 9 minus 97. It is not 9 plus. 9 minus square root of 97. 14 minus 9 plus. Here it becomes plus. Now what happens? Here it becomes plus. What happens? Put y is equal to 1. That shows 6x is equal to minus 1 by 2 into 5 plus square root of 97, which implies x is equal to minus 1 by 12 into 5 plus square root of 97. This is from equation 2. You please follow the procedure. This is from equation 1. Now we have got, for the value of y, we have got the values of x. Now from equation 1 and 2 we will combine. From equation 1, what is the answer? X is equal to 6 by 5 plus square root of 97. Plus square root of 97, and y is equal to 1. From equation 2, x is equal to minus 1 by 12 into 5 plus square root of 97. Six x is equal to and y is equal to 1. So these are the two eigenvectors. These are called as the eigenvectors. Hence eigenvectors are this. From equation 1 we will call them as x1, y1 and x2, y2. This we call it as x2, this we call it as y2, this we call it as x1, this we call it as y1. This implies, what are the eigenvectors? Eigenvectors are 6 by 5 plus square root of 97 and 1, and second one is minus 1 by 12, 5 plus square root of 97 and 1. These are the two eigenvectors. When eigenvectors are there with you, you can easily write the matrix P. P is equal to matrix P. This is the most important step. P is equal to matrix of eigenvector 1. I am writing it non-traditionally, and you please understand the concept eigenvector 2. Now, what is the value of P? Now, 6 by 5, 6 by 5 plus square root of 97, 1, and minus 1 by 12 from equation square root of 97 and 1. This is the value of P. What is our equation? A is equal to P inverse AP. For the above matrix, you can find out P inverse very easily. It's a 2 by 2 matrix. Find out the P inverse. And here it is dP. P inverse dP. And you will get the value of A. And it is not for finding the D. It is for cross-checking. D is already, we know from D is equal to lambda 1, 0, 0, lambda 1. From the eigenvalues, what are the eigenvalues we have got? Eigenvalues already lambda 1 and lambda 2 we know. Hence D is what is lambda 1? Lambda 1 is 9 plus square root of 97 by 2. 9 plus square root of 97 divided by 2. 0 and 0. What is here? It is lambda 2. What is the value of lambda 2? We have already got 9 minus square root of 97 by 2. If you want, you can further reduce this into this form also. And 6 by 5, those are all arithmetics which you can do. 6 by 5 plus square root of 97. For simplification, you can write it as only simplification. That simplification we need not worry. You can write it in the same form also. There is no harm. This can be multiplying and division by 5 minus square root of 97. What happens? So that because it is in the form what you call the other eigenvector is in the form of 5 plus square root of 97. Let us try to do some what you call little bit of arithmetics here. That is equal to 6 into 5 minus square root of 97 whole divided by 25 minus 97. That is equal to 6 into 5 minus square root of 97 whole divided by 72. That is equal to 6 into 5 minus square root of 97 whole divided by 72 is equal to 5 into 5 minus square root of 97 whole divided by 12. It is minus 72. It is minus 72. It is minus 12. That is equal to minus 1 by 12 into 5 minus square root of 97. You can replace this value with the value which we have found, so that ultimately what we have got, the answer is P is equal to minus 1 by 12 minus 1 by 12 5 minus square root of 97 minus 1 by 12 5 plus square root of 97 1 1. This is the P value. So that it will be easier to find out P inverse and to cross check this particular A is equal to P inverse dP. Then our D is correct or not, we will come to know. Once D is correct, then we will say that that is the value of the diagonalization. We have got the P value. We have got the D value. Cross checking these things you please do. That you treat it as a homework. 9 plus square root of 97 by 2 0 0 9 minus square root of 97 by 2. This is how a diagonalization of a matrix can be done. We have started with a simple, what you call 2 by 2 matrix of very nominal values, not complicated values also. 2, 3, 6, 7, very simple values. But ultimately it has resulted in a very good answer having some amount of what you call complication in it. But however, when you go step by step to find out the P, this is called as the model matrix, and to find out D, diagonal matrix, then we can say that A is equal to P inverse dP and A to the power of n is equal to P into D to the power of n P inverse. This is the most important thing which power of a matrix can be done, especially useful in linear algebra, engineering applications, data analysis and computer science engineering. So that multiplication of a matrix can be derived from the diagonalization also. Once you got the diagonalization matrix with you, then multiplication of a matrix will be very easy task. Otherwise, what happens in a machine, if you are going on feeding A to the power of 100 means it has to multiply 100 times in the traditional way, where once you got the P and P inverse, they are not going to change. It's only D, diagonalization. Once it is diagonalized, to find the power of a diagonalized matrix is very easy. You just see here, D is equal to, once we have confirmed that lambda 1, 0, 0, lambda 2, then D to the power of n is nothing but lambda 1 to the power of n, 0, 0, lambda 2 to the power of n. You see how simply we can find out D to the power of n. Once you know P and P inverse, by finding the D to the power of n, you can find out. Let n be n is equal to 1000 also we can find a to the power of n very easily with this formula. If anything is given in the examination to find a to the power of 1000 means we should not be afraid. If it is a 2 by 2 matrix, fataфат find out the eigenvalues. Immediately you go for the eigenvectors and cross check whether the eigenvectors are linearly independent. When the eigenvectors are linearly independent, automatically it can be diagonalizable. Then, now I want to give a homework to you. Why, when eigenvectors are linearly independent, it results in diagonalization. Certain these things, once you know, it will be easier for you to apply these concepts, and once you have got the eigenvectors linearly independent, then you just see in this equation, they are not linearly dependent on each other. Eigenvectors are linearly independent. Just see here. Eigenvectors x1, y1, x2, y2 are linearly independent. Once eigenvectors are linearly independent, then automatically this results in diagonalization, and once diagonalization is confirmed, then your lambda 1, lambda 2 will come into force, and d to the power of n is equal to lambda 1 to the power of n 0, 0, lambda 2 to the power of n. Let it be even for a 3 by 3 matrix. It's a very simple procedure, but go in a procedural manner, you will get the answers very easily. With this, I want to conclude this lecture. Best of luck to everybody. Thank you for viewing my lecture. Thank you for listening to me. And if you feel there is a value addition to your knowledge because of this lecture, please share my channel details and subscribe to my channel. Maths and Science by IITian. Thank you. Best of luck.